Okay, so let us start this once again. Okay, so we got through this oblique collision and we were trying to understand what actually happens. I gave you this question that if the impact parameter is 2r by 3, then find the particular velocity of. No, means that's just a word which we are utilizing. Okay, it is not of that much big. It's not of that much big use. No, no, you do not have to use right now for your level. It's not required. Okay, sometime later on, when I'll be doing impulsive kind of collisions, impulsive force and all, at that time it might be utilized a little bit, but right now it's not utilized. Okay, so that's a little bit advanced topic, but we should be aware of this word impact parameter. That's all. Okay, yeah. So did you try this question? Hmm. What are your answers? Hmm. Okay. Let us just see what happens when they will collide. So they got collided over here. Okay. And the gap between their impact means the gap between their centers is known to us. This length, we know that this length is going to be 2r, isn't it? This yellow line is going to be how much? 2r. So, but we know this length also, that this length is 2r by 3 and this length is 2r, isn't it? I call it as O or call it as A, B and C. Word or not? So if we look into triangle ABC, this is my condition. This is A, this is B, and this point is C. So AC is very good, 2R by 3. This is 2R. Word or not? So let's suppose if I just take this as angle theta. So this one will be also angle theta, isn't it? Now velocity V0 was in this direction. Yes, this is my direction of velocity V0. So V0 will have two components during the time of collision, one along this side, one along this side, isn't it? So what I'm doing is I'm just drawing the diagram for A directly. So A has two velocities. Uh, okay, let me just decrease this. And this is V0. This angle is theta. So V0 cos theta and V0 sin theta. Thus I'm raising this question. Okay, is that clear? Now at that time it collides with B. If you look into that, the line of impact is same, which passes through AB. This is my line of impact. So along the line of impact, okay, let me just write this velocity a little bit later on. Along the line of impact, this is my line of impact, isn't it? So the velocity of A along the line of impact is known to us, which is V0 cos theta. But along the line of impact, the velocity of B is how much? 0 before the collision. Now, after collision, what will happen? After collision, along the line of impact. So one thing is damn sure, one thing is particularly damn sure, that the A will have the same velocity perpendicular to it, isn't it? Let's suppose this is V naught sine theta, but along the line of impact, since E is not equal to 1, its velocity will be different. I call it as V dash. I call it as how much? And similarly for B, it will get some velocity along the line of impact. Okay, I call it as V double dash. Are you able to get me or not? Yeah, VB dash, and this is VA dash. Are you able to get me? Is this is going to be the equation? So similarly, let's suppose if I want to find this, like I wanted to calculate this angle theta. So sine theta is perpendicular, which is 2r by 3 divided by 1 by 2r. So which is equal to how much? 1 by 3. So if you calculate cos theta, you'll get same thing. It is perpendicular. Okay, so it will come as 2 root 2 by 3. Check that. Is that clear or not? So we got our thetas, but we need to calculate this VA dash and BB dash, then only we'll be able to know the velocities of A and B. So along the line of impact, if I apply law of conservation of momentum, so along line of impact, applying law of conservation of momentum. If we apply that, then what it will be? Simple, like initially the mass 2m has this velocity while the mass m was at rest. This 2m has some another velocity while this mass m has also some velocity. So equation will be 2m into v naught cos theta, that must be equal to va dash 2m into va dash plus m into vv dash. M cancel. Twice v naught cos theta is 2 root 2 by 3. So this is okay. I'll just write in terms of v naught cos theta. Okay. So twice v naught cos theta is equal to twice va dash plus vv dash. Is that clear or not? Also, along the line of impact only, I can apply coefficient of restitution. Okay. Along LOI. Okay. E is equal to velocity of separation, that is VB dash minus VA dash divided by V naught cos theta, isn't it? So VB dash minus VA dash is exactly equal to, I'll write over here, no need to make it congested. So E is equal to VB dash minus VA dash, because that's my separation velocity, divided by uh, approach velocity, relative velocity, which is V naught cos theta minus 0, isn't it? So VA dash minus VB dash minus VA dash is exactly equal to E is given 1 by 3. So 1 by 3 V naught cos theta. Is that clear or not? बातें समझ में आ रही हैं? So now if I got my V naught cos theta, I can easily write this VB dash equation. So let us subtract both of them, isn't it? So what I'm going to get, VB dash will be cancelled and this will be thrice VA dash, isn't it? Is equal to twice V naught cos theta minus 1 by 3 V naught cos theta. Okay. Minus 1 by 3 V naught cos theta. So VA dash appears as 3 to the 6, 5 V naught cos theta divided by 9. Is that clear? And similarly, VB dash, if you put this over there, it is 5 minus, so it is 8 V naught cos theta, 5 3 plus 5 3 8. So 8 V naught cos theta divided by 9. Are you able to get me or not? So these are my velocities after the collision. So look over here. So therefore, we can clearly see that for A, there is a resultant velocity in this direction or not. Because I have two components of velocities. Are you able to get me? It can be anywhere in any direction. We need to find it. We'll see how to find it. Okay. So look over here. What is that resultant velocity of A? Therefore, this implies finally V of A after collision is exactly equal to root under V naught sine theta, which is V naught sine theta is V naught square, sine theta is I think 1 by 3, so 1 by 9 plus VA dash is 5 V naught, so 25 V naught cos square theta is 4 into 2 divided by 9 nines are 81 into this 9. So this much big long you will get something like that. Are you able to get me or not? Is that clear? But V of B is very simple after collision. So this is why oblique collision is hard, because it is mathematically tough, not in terms of physics. It's in terms of mathematics why it is tough. Okay. So VB dash will be simple. 8 V naught cos theta is 2 root 2. So I'll write directly 16 root 2 V naught by 9 3 is a 27. This is your answer of VB and V. VA uses calculate. Are you able to get me? Is this clear? Okay, can I move ahead? Let us try one more question. Okay, let's suppose, let me just draw a line first. Okay, so let's suppose I am throwing a sticker on two caroms. Okay, placed like this way. Wide or not? Each has, yeah, each has mass m and radius r. Okay, and this one is projected with velocity v naught. Got it? Question is, if e is equal to 1 by 3, find velocity of, let's suppose this is a, this is b, and this is c, and find the velocity of a comma b comma c after collision. Do it. Yeah, B and C are at rest. This is an awesome question actually. Okay, should we do? Okay, so what will happen if they collide? Let us just draw that line. Okay, this is how the striker is going to hit, isn't it? Now here, the question is a little bit different because it has, if you see over here, it has two basic, 1 minute. I think I'll erase this yellow line right now. So it has two important things to consider about that. We have over here two line of impacts, isn't it? So the first conclusion, the first mistake which people do, they do not draw the two line of impacts. So always draw the two line of impacts. Right or not? Now remember that this particular ball was having a velocity v naught along this direction before collision, isn't it? So now whatever happens, see, if I just block, see, these are my same masses, so they are just trying to block the particular objects over here or not. So look over here. If I see this is my impulse 1, this is my impulse 2, and if I look over here, if you look into these triangles, if I see particularly, you see one thing, that this is distance to r, this is distance to r, and this is distance to r. So how much angle they make? Yeah, so they are making 60-degree with each other, isn't it? So this is what is actually its conclusion. Like you can feel like this is my mass m, which has some velocity v naught. These two masses were at rest, and after collision, what is happening? The mass m, and at that same instant, the other two masses, okay, will get the velocity along the line of impact only, isn't it? So let's suppose this mass gets some velocity, this mass gets some velocity. But what about this mass? If two blocks are starting to move forward, this mass must move backwards so as to conserve the momentum, isn't it? Got it? So I'm just, you can take even forward direction, but you will not get anything. So this is going to be 30 degree. This is going to be how much? 30 degree. And this is, let's suppose, I'm drawing it. Let's suppose this is the velocity of ball B, and this is the velocity of ball C. So this ball moves in which direction? Backward direction, isn't it? So this is velocity of ball B, velocity of ball C, and this is velocity of ball A, where this is A, B, and C. Are you able to get me or not? Is this clear? So V of A, V of B, V of C, V of A, isn't it? Now, momentum cannot be conserved in both direction x and y here because the impulsive force is in both the direction x and y both direction, isn't it? Like this, I can resolve in both the ways. So here impulsive force is present in which means direction, both direction. So you have to conserve the momentum in both x axis and y axis. Are you able to get me on that? So let's suppose if I just resolve these velocities. How come it is resolved? So we have V of B sine 30, V of C sine 30, and this is V of A, sorry, V of B cos 60, cos 30, and this is V of C. Okay. Yeah, let us see that. So according to momentum conservation, P of x initial is equal to P of uh, x final, because in x direction there is no external force, isn't it? So this implies P of x is initially only one mass was moving, mv naught. Px final is m minus of mva, which is opposite, plus mvb cos 30 plus mvc cos 30. Is that clear? So m got cancelled, and v naught is equal to vb cos 30 is, how much is cos 30? Root 3 by 2, no? Let us just make it let us make it just cos 30. So vb cos 30 plus vc cos 30 minus va. This is your equation, first equation. Now similarly, if I just apply momentum conservation along y direction, py initial is equal to py final. Now look over there. Py initial, initially there was no py, so 0. Py final is, this one is upwards, so mvb sine 30, and this one is downwards, so minus of m bc sine 30. So this gives me that v of b must be equal to v of c. Is this clear or not? Is that clear? Now let us move to next checkpoint. And last is we are aware of coefficient of restitution. So E means velocity of separation. So question arises, what you are going to write as velocity of separation? Tell me. Hmm. Yes. So here, yeah. So we picked up the point. Here, sir, there are two lines of impacts, isn't it? There are two lines of impact. Remember that. Here there are two lines of impact. So there are two coefficient of restitution equation. Okay. So this is my 1 minute M A. This is B mass M. Got it or not? So B is going along the line of impact only, but A is going with a different velocity, isn't it? So V naught and this is VB. Are you able to get me or not? Is that clear? And while this angle is 30 degree. Is that clear? Similarly, I can take for A and C. Take. So C is going like this way, and A is like this way, isn't it? So V naught, and then once again, this angle is 30, and this is V of C. Are you able to get me? Is that clear? So this is what is the biggest confusion which people face in three different bodies collision, three bodies oblique collision. Okay, but there is no need to confuse as it is very simple. So this is way of C. Got it or not? So see, first equation is formed. Two equations are formed. This is my second equation. This is my first equation. And if I can create, because there are only three variables. See that one, two, three. Yeah, three equations. So you can form any of the line of impact formulas and you can get the answer. So I'll form only one. You can check that. So I'm considering the impact equation for one first case. Okay. So E is equal to VB is going towards that side. So velocity of separation is VB should be more. VB minus. If you look into that, if I resolve VA, then it has two components, isn't it? One along this side, one along this side. Are you able to get me? And this angle is also going to be 30. So this is VA cos 30. This is VA. How come it is V not? It is VA now. Sorry, I have to write VA. I forgot. After collision, the velocity will change now. Yeah. So VA B. Okay. So the equation becomes V of B plus VA sine 30. Sorry, cos 30 no? Cos 30 divided by velocity of approach. What is velocity of approach? Tell me. B was at rest or not? B was at rest. So if you look into that, try to understand. See that. Here is my here is my B and here is my A. This is after collision. This case is appearing after. How come it is just P naught? I need to always take along the line of impact now. Did you forget? At 30. Yeah, V naught cos 30 minus G. Got it all. So E becomes VB plus VA cos 30 by V naught cos 30. So equation is VB plus VA cos 30 is equal to 1 by 3 V naught cos 30 and VB बराबर VC, तो इसको चेंज कर लो, it will be twice VB cos 30, ठीक, minus VA is equal to V naught. Are you able to get me or not? So just divide by cos 30 or multiply. You will have to see that. You just try to solve it. Okay. Is that clear? Just divide by cos 30. You will get the answer. Just divide and apply substitution and all. So you can solve this and you will get that same answer of V and BB cos 30 and all. Okay. So that's your task to do. Right or not? So this is how we will do. This is one of the toughest problem. Okay. It's given in iRedoc, but you can do it is in an easy way. Okay. Can we move to next problem? Okay. Now look over here. Let's suppose there is a triangular lamina. Okay. And on top of it, a ball is dropped from certain height h. I'm just dropping a ball. Got it? Now, thing is, this angle is given theta. Okay. And this block has mass, 1 minute. This block has mass 2m. Okay. You can consider, I'll write over here. This block has mass how much? 2m. Well, the ball has mass m. Yeah, so it is dropped from certain height h over here. Got it? The question is very simple. If it is kept, if this triangular lamina was kept on a smooth ground, right, and the value of ball and wedge is E is equal to 1 by 2, then find the velocity of wedge and ball after collision. After collision, do it. Try to do 1 minute. Initially, the wedge is at rest. Of course, it is at rest. Okay. Done. Okay, when the ball will collide, okay, let's suppose this ball collides over here, isn't it? So the ball will have a downward velocity v naught or not. It will have some downward velocity, and that v naught will be nothing but root under 2gh. Yes. But the line of impact, what's my line of impact? Line of impact is like this way, isn't it? Perpendicular to the plane of wage. Okay. That's my line of impact. Yes or no? So we can see that this velocity has two components. One, if this angle is theta, we know that this angle is also angle theta. So V naught cos theta and then V naught sin theta. Isn't it? That's my case over here. But that is for ball. That is for which case? Ball over here. Yeah, which is of mass how much? M. What about 2m? What about initially at rest, but after collision, the 2m will start moving towards which direction? Left side with some velocity v1, isn't it? So let's suppose along the line of impact, if I want to resolve it, green man represents all the 2m resolutions. Okay. So it wants to go with velocity v1. So if this angle is theta, this angle will be also angle theta. So v1 will have once again two components. v1 cos theta and v2. Achha, 1 minute. Sorry. Correct. v2 cos, v1 cos, v1 sin theta. Now v naught sin theta and v naught cos theta are the velocities initially now. They are initial velocities. After the collision, the ball will start moving in which direction? Means it will have the velocity component along the line of impact. I call it as v2. So v1 and v2 are final velocities of the waves and ball after the collision, while v0 is the velocity before the collision. Is that clear or not? Okay. So now I can have a resolve. This is so big equations. uh, I just can perpendicular to the line of impact. Should we do perpendicular to the line of impact or should we go vertical and horizontal? Parallel to the line. There are two ways to do it. Okay. What? Even I'm not aware which one is easier. even I'm not aware, even I'm not aware which one is easier, go ahead or not. I will just apply. So along, but actually see the force is actually present. See the external force is present in the vertical direction, and along the line of impact only we can apply the law of conservation of momentum, isn't it? So let's do along the line of impact. Along the line of impact, the mass m has velocity v naught cos theta, isn't it? That must be equal to that if I'm taking downward as positive, upward I have to take it as negative. So let us take it negative only. Okay. So minus of mv naught cos theta must be equal to uh, the velocities after that, which is minus of mv1 sine theta, isn't it? Plus and plus sorry, this is minus of twice mv1 sine theta, because finally the twice m has v1 sine theta velocity along the line of impact. So twice m minus of twice m v1 sine theta plus m sine theta plus m v2, just m v2. Are you able to get me or not? So this is my first equation. Is that clear? Are you able to get me now? Next equation will be perpendicular to the line of impact. The momentum is also not conserved, but still we can write the equation that initially there was no momentum. Like we can just take that, okay, perpendicular to the line of impact. Why perpendicular to the line of impact? Because uh, along that direction the external force is also how much? Zero. Are you able to get me or not? So perpendicular to the line of impact, the equation will be twice, means initially the velocity was, if I'm taking downward as minus, so minus of mv naught sine theta is equal to, finally I have got twice mv1 cos theta in the upward direction. Are you able to get me or not? But the ball does not have any kind of velocity along that direction, so there is no condition for that. Is that clear? Are you able to get me? Let us see. So mm cancel, and this is v1 is equal to minus of v naught by 2 tan theta. Are you able to get me? Now applying the coefficient of restitution equation along the line of impact, E is exactly equal to 1 by 2, and that is exactly equal to velocity of separation and velocity of approach. So velocity of separation is how much? v2 minus plus v1 sine theta divided by how much it is that it is v naught cos theta. Are you able to get me? Is that clear or not? Because initially it was only v naught cos theta. Are you able to get me or not? That will be minus of v naught cos theta. Is that clear? Okay. So if I just write, the equation will be something like it will be v2 plus v1 sine theta is equal to minus of v naught cos theta divided by how much? 2. Is that clear or not? So you have three different equations. If I just solve this, 1 minute. Initial momentum is equal to final momentum. Initial momentum was mv naught cos theta along this direction. I'm taking this as downward. And twice, twice. Okay, let us go through the vector form only. Okay. So m cancel. It will be minus of v naught cos theta is equal to minus of 2v1 sine theta plus v2. Are you able to get me or not? Is that clear? Then you have V naught sine theta as twice of V1 cos theta, or you can write V1 cos theta as minus of V naught by 2 into sine. V naught cos theta, how come? This is correct only. This is perpendicular to the line of impact equation, okay? And then it is V2 plus V1. Then I have got this equation V2. Achha, I can just solve. There is no requirement of this equation perpendicular to the line of impact. And directly put it in this. This equation is, I think we can write it as, what is that? This is V2 minus twice V1 sine theta is equal to minus of V naught cos theta. Are you able to get me or not? So if you just solve it, usually people do not use sign convention to solve it. So if I just subtract it, this will be plus. So thrice V1 sine theta is equal to, this will be plus. So this will be twice V naught minus V naught. So V naught by 2 cos theta. So V1 is going to be equal to V naught by 6 cot theta. Are you able to get me or not? So that is your equation. Okay. So the question arises that are you going to follow this or this? Like I have, if I write the perpendicular to the line of impact equation, V1 is equal to minus of V naught by 2 tan theta. This is appearing over here, isn't it? But although it is appearing, but this is not correct over here. Remember that. Is that clear? Not correct, because here what is happening is that when I have written this equation, I have just taken that these two are equal to each other, but we do not know whether they are equal or not. Okay, because V1 is not known to us. Is that clear or not? Okay, so we just ignore this equation. Are you able to get me or not? Mm, yeah, you all see the law of conservation of momentum. We have to always apply along the line of impact, and coefficient of restitution also we have to apply along the line of impact, because we know that along the line of impact the net force is always zero. Are you able to get me or not? Is that clear? So we have put it that equation already into the consideration. So that's why we have got V1 is equal to V naught cot theta. If you replace in any of these equations, V1 is equal to V naught by 6 cot theta or cos theta by sin theta, then you will get the equations of V2 also, which will be a positive number. Is that clear or not? Are you able to get me? Okay, so this was your calculation for this particular case. There is one more question which I am giving you as a homework. Okay, this must be done by you, and tell me. Of course, inclined planes are hard, but they are good to solve. I love this kind of problems. Okay, so once again, you are told that this angle is theta, and the body is dropped from certain height h. Okay, the point is very very simple, that if sorry, बोल रहा है कि लेट सपोज this block remains at rest always. 1 minute, let me just see this. Yeah, so plane is not moving, plane is fixed. Let me write, the plane is fixed always. Okay, so when the ball will come, it will jump, isn't it? So the question is very simple. find the condition of E. What you have to do? Find the condition of E. I'm writing the question. Find the value of E for which ball after collision becomes horizontal. If this is mass M and this is not required, the mass of wedge is not required. Find the value of E such that the ball becomes horizontal after collision. If you want to write, just consider that the mass of wedge is capital M. Okay. So this is your question as a homework. You try to do, it's similar to this one, line of impact you have to think. Means try to resolve the velocity along line of impact. Simple, when it will collide, I'm just giving you the hints. Okay, 1 minute. So when it will collide over here, the ball will have originally its V0 velocity, V0 which is equal to root under 2gh, isn't it? Means this velocity root under 2gh will be downwards. Then this V0 will have two components, one perpendicular to the incline, one parallel to the incline, isn't it? This angle is theta, so V0 cos theta, V0 sin theta. The line of impact is also along this direction only, isn't it? Line of impact is also in this direction. So when the ball will fall, means the ball after collision will have some velocity along this direction, along the line of impact, isn't it? I call it as V1. And this velocity u is also 0, v is also, v2 is also 0. Are you able to get me or not? Is this clear? So just resolve along the line of impact and you'll get the answers. Okay. So find the velocity. Okay. The question is find the velocity of which for which the ball becomes horizontal after the collision. So the important point is you have to think that the resultant should always become this. This is the final value. Okay. Do it and then send me the solution. Okay. Okay. Chalo. Let me just stop the recording.